Here we are, Statistics and Mechanics, Year 1, Chapter 6, Question 15 of the mixed exercise, Statistical Distribution. So, Question 15 then. An archer hits the bullseye with a probability of 0.6, 60%, alright. She shoots 20 arrows at a time. Find the probability that she hits the bullseye with at least 50% of her arrows she shoots. Okay, so we have got the distribution binomial, and she is taking 20 shots, and she has a probability of 0.5. No, she doesn't. She has a probability of 0.6. You see how they've worded the question to get you muddled up between which bit you want. Okay, now to find the probability she hits with at least 50% of her arrows. 50% of 20 is 10. So probability that she has at least, so that is greater than or equal to 10, which is equal to 1 minus the probability of x being less than or equal to 9, because we want the 10 included, so we don't include it over here. So putting this into the calculator, then we end up with, let's just come over here. So we just come back here to the here. So we've still got 20 as a number of trials, and her probability now is 0.6 of the arrow shots. Okay, and we are looking for the probability of it being less than 9. Okay, 1275. Okay, so 0.1275. So 1 minus that. Okay, onto the calculator. 1 minus 0.1275. Okay, and we get 0.8725 as a probability that she hits 50% of her shots. Brilliant. Right then, she shoots 12 sets of 20 arrows. Find the probability that she hits the bullseye with at least 50% of her arrows in 7 of the 12 sets of arrows. Hits the bullseye. So we want to take this probability that she does that 7 times out of the 12. So the probability that it's greater than 10 is this. And so we can say the probability that x is less than 10, i.e. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, would be 1 minus 0.8725, which of course is the 0.1275. So we want to do it that it's 7 out of the 12. So we are going to hit 0.8725, and we're going to hit that 7 times, and then we are going to hit the 0.1275, then not hitting it 50% of the time. So from 7 up to 12, 1, 2, 3, 4, 5 to the power 5. And when we put that into the calculator, okay, 0.8725 to the power 7 times by 0.1275 to the power 5 for the times that we missed. Okay, we end up with 0.12341296. Seems a little bit low. It seems low because it is low. So not only do we need to take that, that would be one way, but there's multiple ways that we could do it. That there is the probability of them hitting the 50% or more 7 times and then missing it 5 times. What about if they hit it 6 times, then missed it 5 and then hit it 1 more? So we need to do the combinations of all of the ones, which of course is going to be your NCR. So we need to put your NCR of 12 and 7 on here as well, which is 12 NCR 7, 792, and we need to multiply that by the 0.000012996. And we get 0.01026. Okay, so the probability that she hits a bullseye with at least 50% of her arrows in 7 out of 12 attempts of arrows or sets of arrows is 1%. Okay. What about part C? So find the probability that she hits the bullseye with at least 50% of her arrows in fewer than 6 sets. Okay, so we need to do the probability. We need to have a new binomial. Okay, so if we have a new binomial where she is taking 12 attempts to hit it, okay, because she's using 12 sets of arrows, and the odds of her getting this 50% in each of these 12 sets is back here on the 0.8725. Okay, and now we are looking at the probability of y being fewer than 6. So that's going to be 5 or more, or 5 or less, isn't it? Okay, which can be the probability of y being less than or equal to 5. Okay, which we can put straight into the calculator. So we're now on 12 attempts of this. We are on 0.8692. 8692. Okay. And we want it to be fewer than 5 on this one. Okay. And you can see it right down there. 0.30283. 0.283. Okay. That isn't quite the correct answer. It's a little bit out. Just looking back at that, it's 0.8725. So checking the calculator, 0.8725, just go back here, 0.8725, that's not what we've got in here, 0.8725, okay, and we want 5 on that one. Here we go, 240, okay, that sounds better, 240, that's a lot better. All done then. Just the challenge question to go.